Bright Duty. Every student matters.
The first question we have here is, why is sodium kept immersed in kerosene? So the reason for this is that sodium is a highly reactive metal. Because of it, it reacts with the oxygen present in the air, and it also reacts with water in form of moisture or any form and catches fire. Because it shows such vigorous reactions with air and water, to store it we have to keep it away from both these elements. And so we store it dipped inside a kerosene oil. So we take a jar of kerosene oil, we dip the metal in it, and that is how it's kept to keep it safe from reacting with atmospheric moisture or with oxygen. The next question is, write the equation for the reaction of iron with steam. Now iron is not the most reactive metal. Because of its low reactivity, it does not react with water in form of room temperature water or even in form of boiling water. Rather, it only reacts when present in the form of steam. That is why it shows this reaction Fe3, 3Fe plus 4H2O reacts to form Fe3O4 and 4H2. This reaction shows that hydrogen gas is liberated, and the reaction is similar, that metal with water forms oxide and hydrogen is liberated, but this reaction happens only when water is present in the steam form. So do remember to mention the states of molecules here. The next is calcium and potassium with water. Now calcium reacts with water to form calcium hydroxide and H2. Potassium also reacts with water to form potassium hydroxide and H2. To balance this equation, we would have to put a 2 here. And now this equation is balanced. So upon balancing this equation, you see that there are 4 hydrogen atoms here, 4 hydrogen atoms here, 2 here and 2 here. Oxygen is also balanced and potassium is also balanced. So these elements, being highly reactive, form hydroxide, whereas this iron forms oxide. Samples of 4 metals A, B, C, D were taken and added to the following solutions one by one. The results obtained have been tabulated. So we have 4 metals A, B, C and D, and they are reacted with iron sulfate, copper sulfate, zinc sulfate and silver nitrate. The reactions noted are as follows. So wherever there is a no reaction, it's mentioned, and where the displacement takes place is again mentioned there. So based on this, we have to determine what is the most reactive metal. What would you observe if B is added to the solution of copper sulfate and arranging the metals? So before we get into this, let's make equations based on these reactions. Now we know that A, when reacts with ferrous sulfate, there is no reaction. That means A is less reactive than iron, right? Similarly, when we see for all other reactions, so A plus copper sulfate causes displacement, which means A is more reactive than copper. So A lies somewhere between iron and copper. It is more reactive than copper, but definitely less reactive than iron. Similarly, we'll do it for B. So B, when reacts with FeSO4, this displacement means it is more reactive than iron. So B would be somewhere here. Now B on reaction with zinc sulfate shows no reaction, as you can see here. So again, it is less reactive than zinc. So as we go on making these equations, again FeSO4 plus C forms no reaction. Therefore, C is less reactive than iron. C is also less reactive than copper, and C is also less reactive than zinc. So C is less reactive than copper, zinc and iron, all of them. And D on reaction shows no reaction with anything. It means it is the least reactive elements of all. So let's first arrange them and then we will see how they work. So we know that B lies somewhere here, and C, because it does not react with iron, copper or zinc, is here, and D does not react with even silver, so it's here. So we know that D is the least reactive and B is the most reactive element. So the first part is answered here, that B is the most reactive because it is displacing iron and no other element is able to do that amongst these 4. If B is added to the solution of copper, okay, so let's read the second part. What would happen if B is added to the solution of copper sulfate? Now as you can see, copper is less reactive than all these elements, And so when this reaction would occur, B being more reactive would cause a displacement in this reaction. So a reaction would occur and copper would be displaced from its salt by this metal B. Now we have to arrange in the decreasing order of reactivity. So B is the most reactive, then A, then C and D. How did we establish this? We established this based on these equations that elements which are highly reactive like B comes here between iron and zinc, then A is even lesser, it's somewhere between copper and iron, and these again are further down the lane. So the next question is, which gas is produced when dilute hydrochloric acid is added to a reactive metal? Write the chemical equation when iron reacts with dilute H2SO4. It's a very simple reaction. Iron reacting with H2SO4 forms FeSO4 and H2. So the hydrogen is removed, it is displaced from the acid and is released in the form of gas, and FeSO4 is formed. What would you observe when zinc is added to the solution of iron sulfate? Write the chemical reaction that takes place. The 2 here signifies the valency. So iron shows both valency of 3 and 4. As you've seen, it forms Fe3O4, and because of its varying valency of 2 and 3, we have to keep in mind the valency. So that is why it's written 2 here. So what would you observe when zinc is added to the solution of iron sulfate? Write the chemical reaction that takes place. So zinc would react with FeSO4. As you know, zinc is higher up on the reactivity series. Zinc would displace iron, iron would get removed. And zinc sulfate and iron would be formed. So this is how this reaction would occur. Which of the following pairs will give displacement reaction? NaCl and copper metal. Now copper is less reactive than iron, and that is why it will not be able to displace it. MgCl2 and aluminium. Now again, Mg is more reactive than aluminium. Magnesium is more reactive than aluminium, and again that is why it will not show displacement reaction. FeSO4 and silver metal. Silver is amongst the least reactive metals, and iron falls in the medium category of reactivity, and that is why the no reaction would be occurring here, because silver will not be able to replace iron from its compound. But AgNO3 and copper metal, now silver is further extremely down near gold and platinum and mercury, so silver is a lower reactive metal, and copper lies above it in the reactivity series. That is why it would be able to displace it. So this is the only case in which displacement reaction would occur, because copper being more reactive than silver. What are amphoteric oxides? So we have already studied this. Ampho means 2. So amphoteric oxides means any oxide which shows both behaviors of a metal, of an acidic nature and of a basic nature. So oxides of metals which have both acidic as well as basic behavior are known as amphoteric oxides. Amphoteric oxides, there are 2 examples. One is aluminium oxide and one is zinc oxide. They react both with acids and base to form salt. So they have a mixed nature of acid and base. Name 2 metals which will displace hydrogen from dilute acids, 2 metals which will not. So we have to talk about hydrogen here. So anything that is above hydrogen in the reactivity series will displace it, and anything that is below hydrogen in the displacement in the reactivity series will not displace it. So if you think of above, we have sodium, potassium, magnesium, zinc, iron. You can name any of these 2 metals. If you think of below hydrogen, we have mercury, we have gold, we have silver, we have platinum. You can again name any of these elements and they would all not, the answer would be correct. All of these, so we have given mercury and gold here, and iron and zinc. So mercury, anything that is above hydrogen starting from sodium, potassium, aluminium, magnesium, zinc, iron, all of these would displace hydrogen, whereas anything that is below hydrogen like gold, platinum, silver would not. Again, so I've given mercury and gold, you can pick any 2. Differentiate between metals and non-metals based on their chemical properties. Now we know that metals have extra electrons, so metals are electropositive in nature. They have 1 to 3 extra electrons in their outermost shell, whereas non-metals are electronegative in nature. They tend to take electrons from other elements to form compounds. So because of this, they react with oxygen to form basic oxides. They react with water to form oxides and hydroxides. As you have studied in the reactions we have done in this exercise also, you have seen that they show different reactions where they form oxides and hydroxides with water. Some metals may react with cold water, some with hot, and some with steam. So they may react at different levels, but most of them show this reaction. So the first property that we have taken about is oxygen, the second we have talked about is water, and the third is with acids. So they react with dilute acids to form salt and evolve hydrogen gas. Again, that we have studied in the reaction so far, that it displaces hydrogen from acids and forms a salt. But these reactions are not shown by copper, silver, gold, platinum and mercury because they are really less reactive elements, and so they do not show these reactions. They react with the salt solutions of metals. Depending upon their reactivity, displacement reaction can occur. So one metal can react with the metal solution with the metal salt of another different metal, and it can form a displacement reaction if it is in accordance with the reactivity series. So these are the four properties. It reacts with oxygen to form basic oxide. It reacts with water to form oxides and hydroxides. It reacts with dilute acid and displaces hydrogen. Only the elements above hydrogen would show this reaction, not the ones below it. Only those metals will show this reaction. And the fourth point is that they react with salt solutions of other metals. If they are more reactive, they would participate in a displacement reaction. So that is for metals. Now the similar properties for non-metals are that they react with oxygen to form acidic or neutral oxides. So here we had basic oxides, where we have acidic or neutral oxides. They do not react with water and they do not react with acids. They are not capable of replacing hydrogen. So these are the differences between metals and non-metals in terms of their chemical properties. The next question is a simple activity based question. So Pratyush here takes sulfur powder on a spatula and he heats it. So we have some sulfur powder kept in a spatula and it is being heated. So let's put a Bunsen burner here. On being heated, he collects the gas in an inverted test tube. So he puts an inverted test tube over it and a gas is being collected. Now we have to talk about the properties of these gas. So what action will be shown by the gas on dry litmus paper? So on dry litmus paper, there would be no reaction shown, as we have studied in the previous chapter also. For a litmus paper to detect acidity or basicity, it needs to have the very important element of water being present, so that it can dissociate to form H plus, or also known as H3O plus hydronium ions. So if the hydronium ions need to be present, which would only be formed in the presence of water, and that is why in dry litmus it will not show any change in the color of dry litmus paper. But if the litmus paper is moist, then it would the litmus paper would turn red, because sulfur on heating forms oxide, and oxides of non-metals are acidic in nature. So what is the reaction form? The reaction is that S plus O2 forms SO2. It is an already balanced equation, so we do not need to do extra effort there. So what we've understood here is that non-metals on reaction with the oxygen form oxides which are acidic in nature, but to detect the acidity, the litmus paper needs to be moist. What type of oxides are formed when non-metals combine with oxygen? So again, the oxide forms are acidic in nature. Examples can be sulfur oxide, carbon dioxide. And this is again an application based question. So a man went to the door posing as a goldsmith. He promised to give back the glitter of old and dull ornaments. An unsuspecting lady gave a set of gold bangles to him, which he dipped in a solution. The bangles sparkled like new, but their weight was reduced drastically. The lady was upset. After a futile argument, the man beat a hasty retreat. Can you play detective and find out the nature of the solution he had used? So this is actually a practice that happens commonly in many areas, that people come with the solution and they ask you that they would clean your gold jewelry with that solution, but when they do so, the weight of the jewelry gets significantly reduced. And this is a trick often played by conmen, which is done using a mixture called as aqua regia. So we've already talked about aqua regia. Aqua regia is a 3:1 mixture of HCl and HNO3. So we take concentrated HCl and we take concentrated HNO3, and when we mix them in the proportion of 3 parts of HCl and 1 part of HNO3, it forms this extremely corrosive combination called as aqua regia. When you put gold in it, it takes gold out of it and dissolves it inside the acid. So it is capable of dissolving metals like gold and platinum. And since the outer layer is gold, it gets dissolved along with the waste layer. So even though it's shiny because it's been cleaned, but the outer layer of gold has also been removed, and that is why the weight gets reduced. That is why it's also advised to not get your bangles cleaned from any place which is not authentic, because they can use aqua regia and actually remove gold from your jewelry. The last question is, give reason why copper is used to make hot water tanks and not steel. So copper is used to make hot water tanks, not steel, because iron in steel is more reactive than copper, and it also reacts with hot steam to produce ferric oxide, due to which the body of the tank will become weaker and weaker and the copper does not react with hot water. So as we have studied before in this equation above, that iron reacts with water to form iron oxide and release hydrogen gas. We know that this reaction would also occur inside of a hot water tank, because when water is heated, then steam would be produced, and this steam would react with iron and it would lead to corrosion. That is why copper is being produced, because copper does not show this reaction.